Hello, in this video tutorial we will see how to exchange data between WEAP and Excel. Also, we are going to talk about the demand priority variable in WEAP. WEAP will allocate water in the system depending on the assigned demand priorities. To better understand what demand priorities are, we will create scenarios, run the model, and explore the results. This video tutorial covers some sections of the Data, Results and Format chapter of the WEAP tutorial. Those who have not followed all the videos in order and do not have the model in this state can follow this video tutorial by downloading the O5 Basic Tools folder. Close WEAP and double-click on the SEI training model to open the model. Go to the WEAP Scenarios version. Area, revert to version, WEAP scenarios. The model has a river called Main River and two demands, the big city and the agriculture demands. Each one has one transmission link and one return flow. When we created the demand sides, we left the default value for the demand priority variable. For example, right-click on the Big City node and select General Info. We can change the name on this window as well. By default, the value of the demand priority for all the demand sites is 1. To visualize the demand priority for the demand sites on the schematic, go to Schematic, Change Priority View, and select View Demand Priorities. We see a number in parentheses next to the name of the demand site. WEAP will allocate water considering the demand priorities. The demand priority indicates the order in which WEAP should meet the water requirements based on the available supply. By default, priorities can vary from 1 to 99. With 1 being the highest priority and 99 the lowest. The lowest priority can be changed in general basic parameters. These priorities are useful in representing a system of water rights and during a water shortage. Higher priorities are satisfied as fully as possible before lower priorities are considered. If priorities are the same, shortages will be equally shared. Typically, you will assign the highest priorities, lowest priority number, to critical demands that must be satisfied during a shortfall, such as a municipal water supply. You may change the priorities over time or from one scenario to another. The values are not important, just the relative order. For example, in this system, the stream flow is 1.5 cubic meters per second. The agriculture demand is 1 cubic meters per second, and the domestic demand is 2 cubic meters per second. The water supply is insufficient to meet the water requirements of the system. If we assign the demand priority as 2 for the agriculture demand and as 8 for the domestic demand, WEAP will allocate as much water the agriculture demand needs first. Then, if the supply is sufficient, WEAP will allocate water to the domestic demand. Because the agriculture demand is 1 cubic meters per second, there is still 0.5 cubic meters per second available for the domestic demand. The agriculture coverage will be 100%. For the domestic demand will be 25%. If we do the opposite and assign the demand priority as 6 for the agriculture demand and as 5 for the domestic demand, WEAP will allocate as much water the domestic demand needs first. Then, if the supply is sufficient, WEAP will allocate water to the agriculture demand. Note that the location of the water intakes is not important. WEAP will allocate water considering the order of the demand priorities values. Since we assign a higher demand priority to the domestic demand than the demand priority of the agricultural demand, and even more, the water requirement of the domestic demand is 2 cubic meters per second, the supply is insufficient for the agricultural demand. The agriculture demand coverage will be 0%, and for the domestic demand will be 75%. We could also assign the same demand priority. In that case, shortages will be equally shared. If we assign the demand priorities as 1, WEAP will estimate a supply delivered so that the coverage is the same for the demands that share the same demand priority. Remember, the location of the water intake does not determine how WEAP will allocate water. WEAP will estimate the supply delivered with the constraint that the coverages must be the same. In this case, the values that fulfill these conditions are a supply delivered for the agriculture demand of 0.5 cubic meters per second and for the domestic demand 1 cubic meters per second. The coverage is 50% for both demands. We can solve this same problem using Solver in Excel to understand it better. You can see here the results. 1 cubic meters per second for the domestic demand and 0.5 cubic meters per second for the agriculture demand. These values meet the constraint that the coverage should be the same. To summarize, the demand priority is an important variable in WEAP. WEAP uses this variable to allocate water within the system regardless of the water intake location. As you see, the results are extremely different for each case. The coverages are related to unmet demands. If you are not carefully assigning the operating rules of the system, you could misunderstand the results. Taking advantage of everything we have been learning during the video tutorial so far, we will create 3 scenarios to evaluate the differences in the results due to different demand priorities assignments. In the first scenario, we will assign the same priority. In the second one, the big city demand will have a higher priority than the agriculture demand. In the third scenario, the big city demand will have a lower priority than the agriculture demand. Go to the data view and access Manage Scenarios at the top. Create 3 scenarios based on current accounts. Equal priorities, priority 1 big city, and priority 1 agriculture, all based on current accounts. We want to evaluate the impact of different demand priority assignments. We can choose which scenarios to calculate by checking the box for each scenario. Uncheck the box for higher growth rate and reference scenarios, and leave only the demand priority scenario selected. Close. Remember that there are 2 ways to edit data. Go to the schematic view. Right-click on the Big City node, select Edit Data, and then the variable to be edited, in this case, demand priority. The second one is directly in the data view. We need to select the element in the data tree on the left and then select the variable from the tabs at the right. In this case, demand sites, big city. Then go to the demand priority variable under priority. We explained the options we have for entering data in the 04 WEAP in 1 hour video tutorial. In this case, the expression is a value. We could enter it directly in each scenario. For example, if you want to change the demand priority for the big city node in the priority 1 agriculture scenario, first we need to select the scenario at the top and then enter the demand priority for the big city demand. Enter 2 as the demand priority for big city. This is how we can access the variables and enter data in WEAP. But there is another option, and it is by exchanging expressions with Excel. Go to the Edit option at the top and select Export Expressions to Excel. It should appear the Export to Excel window. You can export all branches or only the current branches of the element where you are and below. Export the active scenario, which is the one we are editing, or all the scenarios. To export a specific scenario, we must first select the scenario of interest at the top, and then open the Export Expression to Excel window. It is the same for exporting variables. We can export a specific variable or all the variables. If we want to export a specific variable, we must first go to the variable and then select Export Expressions to Excel. We see the demand priority variable because we were in that variable before selecting Export Expressions to Excel. The last 3 options allows us to choose including variables that do not have information, export inherited expressions, and include the autofilter in Excel. Select Branches All, Scenarios All, and Variables Demand Priority. Leave these 3 options like this. OK. We can use this Excel file to assign expressions to the variables on the WEAP elements in the model. We can assign the expression in each scenario to the demand priority variable for the big city and agriculture demand sites. The name of the element is shown in the Level 2 column, the variable in this column, and the scenario is shown in the Scenario column. The expression column shows the expressions that are entered into the model. Blank expressions mean that the expression is either inherited or is the one that we've assigned by default. The demand priority is 1 by default. It means that the demand priority is 1 for all the elements in the scenarios, except for the big city in the priority 1 agriculture. We enter 2 before selecting Export Expressions to Excel. We need to assign the demand priority value to only the equal priorities, priority 1 big city and priority 1 agriculture scenarios. We can filter the scenarios and select the current accounts, reference, and higher population growth rate scenarios. For the big city node, we can assign a demand priority of 5 in the equal priority scenario, 1 in the priority 1 big city scenario, and 2 in the priority 1 agriculture scenario. For the agriculture node, we can assign a demand priority of 5 in the equal priorities scenario, which is the same value that we assign for the big city demand in the same scenario. 2 in the priority 1 big city scenario, and 1 in the priority 1 agriculture scenario. Remember, what matters is the order of these values. For importing these expressions in WEAP from Excel, we need to leave the Excel sheet active. We are editing the Sheet 1 sheet in this Sheet 1 workbook. Go back to WEAP. Go to Edit and select Import Expressions from Excel. WEAP shows from which workbook and sheet the information will be imported. This is correct. Select Yes. When WEAP finishes, it reports the number of imported rows and the number of expressions that were changed. In this case, 12 rows and 3 expressions changed. WEAP does not count an expression if it is the same as the default expression. We assigned some values as 1 and we already had a 2. That is why only 3 expressions were changed. OK. Go to the demand priority to check that the changes were made correctly. If we select Priority 1 Big City scenario, the value was changed from 1 to 2 for the agriculture demand. If we select the Priority 1 Agriculture scenario, the values are 1 for the agriculture demand and 2 for the big city demand. If we select the Equal Priority scenario, the values are 5 for both demands. Before running the model, we can summarize what we are doing. We are understanding how important it is to carefully assign the demand priorities in the model. We will get different results depending on the demand priority values. We created 3 scenarios. In the equal priorities scenario, both demands have the same priority. WEAP will allocate water, trying to meet the water requirement in the same proportion for both demands. In the Priority 1 Big City scenario, the big city demand has a higher demand priority than the agriculture demand. WEAP will allocate water first for the big city. And in the Priority 1 Agriculture scenario, the agriculture's demand has a higher demand priority than the big city demand. WEAP will allocate water first for the agriculture. Besides, we learn how to assign expressions by exchanging data between WEAP and Excel. We are ready to run the model and explore the results. Go to the results view. Select Demand Coverage. Select on this drop-down menu the All Scenarios option to compare the results. For comparing the results among scenarios, you need to exclude the current account year and selecting that year by using the Selected Years option at the bottom. Compare the results only for 1 year. For example, 2002. Go to Selected Years, click on None, and select only 2002. This will be the coverage in 2002 for the big city demand. We can see the coverage for the agriculture demand as well. Explore the big city coverage first. From January to July, the coverage in the 3 scenarios is the same. From January to March, there is no demand from the agriculture node, and from April to July, the available supply is sufficient to cover 100% of both demands. But in August and September, the coverage decreases in the equal priorities and the Priority 1 agriculture scenarios. In the Priority 1 big city, the coverage is 100%. If the demand priorities are the same, both demand coverages will decline to 65% in August and 90% in September. In the scenario where the higher priority is for the agriculture node, the coverage of the big city node is almost 0% in August and 50% in September. From October to December, because the agriculture node has no water demand, The results are the same for the three scenarios. Select the agriculture demand side. Remember that the agriculture demand is distributed between April and September with a peak in August. From January to March, it has no demand. WEAP shows the coverage as 100%. It is important to keep in mind the input data to analyze the results correctly. From April to July, the supply is sufficient to meet the requirements of both demands. Both have a coverage of 100%. However, in August, the coverage varies among scenarios. In the priority 1 agriculture scenario, where the agriculture demand has the priority, the demand coverage is higher than in the other scenarios. It does not reach 100% because the supply is insufficient. In the priority 1 big city scenario, the agriculture coverage decreases to 56%. In the equal priority scenario, both coverages are around 66%. When the demand priority is the same, WEAP tries to meet both demands in the same proportion. We can see the coverage charts for both demands at the same time. First, save as favorite the charts for the coverage for each scenario showing the demand side results. Select all demand sides on the drop-down menu on the right and save the chart as favorite for each scenario. Save the unmet demand for the big city demand. Save the same chart but for the agriculture demand. You should have 5 favorite charts saved. Go to Scenario Explorer. Select from Favorite on the second drop-down menu at the top. Select the 3D option as well on the toolbar at the right. In the equal priority scenario, where there is an agricultural water demand, the coverage of both demands is the same. It will be around 65% in August and 90% in September. It is the opposite in the priority 1 agriculture scenario. The coverage for the big city demand is lower than for the agriculture demand. It reaches in August around 0% and in September around 50%. In the priority 1 big city scenario, the coverage of the agriculture demand is lower than the coverage for the big city demand, reaching around 56% in August and 87% in September. As you can see, assigning the demand priorities in WEAP is very important. The demand priorities should represent how water should be distributed in the system. For example, considering water rights, where the priority is given from the oldest to the latest water rights. Another situation could be considering the location of the water intakes, where water must be distributed from upstream to downstream. You will get different results for each situation. You must pay special attention to the demand priority variable. Besides, we learned how to assign expressions by exchanging data between WEAP and Excel. You can take advantage of these features for managing expressions in WEAP. You can continue exploring the results.